Hi. In this set of lectures, what I want to do is I want to talk about prediction. And I want to talk about this in two ways. I want to talk about how individuals make predictions, and then I want to talk about how collections of individuals make predictions, so how crowds make predictions. What I'm going to do is I'm going to unpack what some people sometimes call the wisdom of crowds. Why is it that collections of people can sometimes make incredibly accurate predictions of things that individuals may not be able to on their own? Now to do this, I'm going to harken back to a bunch of stuff we've already done in this class. So remember, very early on we talked about how you can use categories to make predictions, and by using categories you can reduce the variation that we see out there in the world. And we had this measure r squared, which captured how much of the variation we could explain. Then we moved on from categories to talk about linear models, and we showed how linear models can be even better at predicting patterns of variation in data. So for example, we have a bunch of data that looks like this. We might then run a linear model through that and sort of make predictions based on that linear model. But we knew there were limits to linear models as well, right? And that's why we constructed things like Markov models. We had that Markov model on the percentage of free and unfree states, and we show how that sort of model can be used to predict. So the idea I want you to have in your head as we think about prediction is that there are many models that people could use. And if you've taken a course like this and you've learned all sorts of models, from percolation models to Lyapunov models, to growth models, to linear models, to categorical models, to standing ovation models, that when you think of some real-world situation, you're going to invoke one of those models, and different people are going to have different models, and we're going to see how, by having different people having different models, collectively, we might be really good at making predictions. And in particular, I'm going to focus on something I call the diversity prediction theorem. Now, this goes by many different names, so I'm going to call it the diversity prediction theorem, and that's going to show us how it can be the case that these many models are actually better than individual models, even if the many models are all equally good on their own. So you get the wisdom of crowds effect being the fact that the diversity of models is really powerful. That's why I call this the diversity prediction theorem, because diversity ends up being really valuable in crowds of people getting things right. All right, so that's an outline of what we're going to do. We're going to talk about prediction at the individual level, then at the collective level, and we'll show how having many models results in something we're going to call the diversity prediction theorem, and that diverse sets of models lead to more accurate collective forecasts, and explains what some people call the wisdom of crowds phenomenon. All right, let's get started.